So now let us see how exactly lists are better. Numpy is better than using list and other functionalities. Okay, so maybe here we can compare two lists. Maybe we can do mathematical operation. So let me just get a code over here which I already have it. So I'm just pasting it. So let us just walk through the code. So I've created a list one and a list two. So list one is having from 1, 2, 3, 4, 9, and list 2 is having 6, 7, 8, 9, 10 and 11. So here how many elements does each has? So it has each 6 elements, so equal number of elements, and I am creating a empty list. Okay, so empty list, I am just giving open brackets and close brackets. So this is how we need to initialize an empty list, and then we'll be seeing the length of the list, and we'll be getting the minimum length of it. Okay, so if there is an extra parameter which will not be added. Okay, so basically it will be adding only no, equal number of things. So the shortest way to get it is nothing but getting the length of it and using the minimum function. So it will just return the minimum value. Okay, and here what we'll be doing is we'll be starting with range of 1 going until length of 1. Okay, so as it is same, you can use minimum length also over here. Okay, so we'll be going till there, and we'll be adding list 1, so element of list 1, and in element of list 2 with respect to those index, and we'll be appending to our sum list. Okay, and finally we'll print the list. So again here we have something like a separator. Okay, so you can just go and check with respect to print statement. So maybe you can open here only. If you give just shift tab to your print, here you will get. Okay, so there is something like end, there is something like separator. So each separator is nothing but string inserted between values. Okay, so that's how it has been done. So let us just go ahead and execute this. So here is the sum list is 7, 9, 11, 13, 15 and 20, right? So that is how it is doing. But basically here this is the one way. Okay, so this is what we are doing with respect to list. So we are individually doing. Okay, and also we lack an advantage of creating for different size. Okay, but we can use it using Python. So we have something known as vectorization. Okay, so creating an array 1 with the same number of elements, creating an array 2 with the same number of elements. Okay, so maybe here I have 5 elements itself instead of 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then I'm giving directly as sum list is equal to sum array. Okay, so directly I'm doing addition. So let me just print that. So you can see here it is directly added. So if at all I do the same thing, maybe I'll call it as list sum list is equal to list 1 plus list 2. Okay, let me execute that. Oh, I need to print out the sum list. So maybe I'll call this one itself. So I have this new sum list right over here. It is updated with our sum list. So let us just print that. So here you can see it is like 1, 2, 3, 4. So it is basically appending both. So it is like updating one list with the other list. So mathematical operation is not possible directly with respect to list. You need to do manual way in this way, and then you need to get. But whereas array it is directly doing with respect to numpy. So that is one advantage of it. So the next is like you can do conditional checks. So basically here you can check whether it is a boolean or not. So maybe I'll execute this because I want to use this particular list. Okay, so here I have a function. So let me just get with that function and we'll walk through the code. So condition to check. So we are checking array 1 boolean. Okay, so array 1 we are checking whether each element is greater than 3. Okay, so checking whether the condition is greater than 3, and then what are the values that satisfy the condition. Okay, so which and all values is greater than 1. So let us just go and execute that. So here it is telling false, false, true, true, true. So if you go back and check array 1, it is like 1, 2, 3, 1, 2, which is lesser than 3, which will be a false condition. So that's why we have false, false, and next is true condition. So 3 is equal to 3, and rest all the conditions are true. Okay, so here we are checking array 1. Okay, so it is updated with this array, not with this list. Apologies. So we are using array 1. So here you can see directly you can check with respect to conditional check. So here it is returning boolean, so you can check out other also. So maybe you want to create a list, after you want to modify your array with only values, maybe something like greater than 2. So you want to retain this, you need to modify it. Okay, so you can modify in this way. Okay, so you can just send array 1 in open brackets, array 1 should be greater than 1. Okay, so if you execute this, so it is creating array, but here we have not stored it. So basically we are having an array 3 4 5. So that is how you can slice some kind of arrays, and also you can create operations on higher levels. Okay, so maybe you want to do subtraction. Here I have a very simple subtraction, so numeric python. So it's a two dimensional array, 1 2 3 4 5 6 11 12 13 14 15 16, and I'm subtracting second array with first array. So let us just print that. So here you can see this number is subtracted with this number. Okay, so this is not possible with respect to lists. Okay, so that is 10. So each individual element is usually subtracted with this. Okay, so this is how you can do mathematical operations. Even multiplication, you can just replace this with multiplication sign, you will get multiplication, division. Okay, and addition also, we are just printing it. So same thing, addition we had already seen here, right? So here, so same thing, so mathematical operation, so that suffices. So next is kind of functions. Okay, so from here we'll learn about functions. So again, in functions, let us just quickly recap. We had seen for loop with creating a range, right? So range is a function which you can tell. So range function can be individually used to get numbers. So similarly, let us just use a function. Let us just create an array with a range function. So numeric Python list of range of 1 to 15 with a step of 2. Okay, so let me just execute that. So it is starting from 1, the step is 2, that's why 3 4 5 6 until 13. 15 is the stop bit, stop number, and we won't be including that. Okay, so that's why it is like this. Okay, so this is how we had created. So there is something called as combination of it. So basically, if you want to create a range array, you can directly use a primitive known as a range. Okay, so that is the a range. So directly it has been creating array a range. So you can see the final outcome is same. Okay, so there are a few ways which are replicated, and also an array with an zeros, you can just create an array with zeros by using the function like 0. So maybe I have examples for both one dimensional and two dimensional over here. So let me just quickly execute that. So it is directly using zeros, numpy dot zeros. So 5 zeros, here it is telling 5 cross 5 zeros. Okay, so you can see 5 zeros, and here it is 5 cross 5, 2 dimensional. You can do 3 dimensional giving another comma 5 over here, so that will become 3 dimensional. Okay, so printing would be like a little hassle, because here after 2 dimensional you are not going to be using the separator anymore, right? Okay, so that is like creating with respect to one, and just not zeros, you can create it once also. So maybe you can just replace this as ones. So once. So let me just execute that. So here you can see zeros are converted into ones. Okay, so you can create maybe like this, and also again you can take numbers like creating between other than 5, so you can take any other, but basically you will be using like zeros and ones. There are primitives like zeros and ones over here. For any other number you need to use something like fill. Okay, so let me just full numpy. So here is a code other than 1 or 0. So full, the shape is 5. Okay, and you are filling with the number 5. Okay, so basically this is the full function which you will be getting. So let us quickly execute that. See, here we are telling full 5, and here it is 5 cross 5 itself, R shape, but we are filling it with number 3. Okay, so like this you can create an array. So maybe again you need to create a random values. Okay, so you can use np random. Okay, so this will create some kind of random values. Again, this random value is usually between 0 and 1. So here we are telling the index or the shape. Okay, so this shape which we are passing it over here, so that is 3 cross 3. Also you can give significance with respect to your random integer. So maybe it should be like in the particular range or something. So here we have like kind of we are using seed function to give c as 2, and then we are giving lowest value to be 1 and highest value to be 15, and also size to be this one. So we are just printing it this, and we are creating the array also over here. Okay, so maybe this you can shift it up and save it somewhere and can just add it. So this is a different size, 3 cross 3. Okay, so this is size of only 10 values. This is 3 cross 3, 2 dimensional. So let us just execute that. So here you can see it is like randomly generated. Okay, so every time it is usually randomly generated where you need to give. Okay, so that's how it is created with respect to a random function. So again, if you are interested, just go with the documentation over here. So you will find array creations. I'm not sure whether random won't be usually there. So full function is what we just saw about here. So this is a very good website which I recommend for any kind of documents you are required. So you can just go and check with respect to dev docs. We can find for many programming languages. Okay, so just a recommendation. So here it is having a whole lot of varieties. So maybe you need to get some function, so maybe it can be doing. So we are discussing like Fourier transform and all. So all discrete Fourier transform are done. So these are known as FFTs. So fast Fourier transform or discrete Fourier transform. You can get time and date support functions. So here you can see you want to create busy days, counts, offset. So similarly, we had created in previously in Python, right? Using the time model. So basically date time. So here you can do date time as strings, dates and all. So you can see over here, you will find a lot of examples. So it is using D type and it is telling time delta. So these are primitives again, D type. So here you have date time delta. We are already seeing this. Okay. So that is how it is. And also any quick documentation, you can just go here, press shift tab and get documentation over here also. So again, remembering each and every function is kind of waste of memory and a lot of time consuming. So I recommend to just walk through the documentation every time you need, so that you will understand better. So especially if you are want to work on random, so you can just come over here and check with respect to this. So random is the function which we are using, and it is placed in alphabetic order, so it is easy for me to get it also over here. So this is what is happening. So directly you are getting the doc string over here, parameters, and what it is just returning. So same thing, if you go and check over here, you will be getting the same thing over here. Okay, so maybe here it is not telling much about parameters, and this documentation does have parameters also. Okay, it is telling size and out and dot. Okay, so that is about randomization. So again, there is something known as line space. Okay, so we can use line space when a let me just copy that. So when a range of the line of size of the output is known, but the step size is not known. Okay, so basically you don't know the step size, so then you can just use line space with respect to this is your requirement, so it should fit within it. Okay, so let us just run this. So here it is telling from 1 2 3 4 5 6, so we needed 6. Okay, and we needed value from 1 to 40, so you don't know step size. So for that something like line space, so lin space. Okay, so that can be used, and also there are so many others. So I think these are the few things, and excluding this we need a few more. Maybe you can find out difference between performance. So I have one particular example for it. So for that we need import time. Okay, so let me just import time with respect to performance also. Instead of using the traditional list method, we can create with respect to arrays also, and see what is the time consuming. Okay, so we'll get the performance of time. So basically list, I'm creating I in the range of some kind of 2 lakh values. Okay, or 200,000. Okay, so here I, and here I'm taking j square. Okay, so this I and j value I have to define it. Okay, it is taking a for loop, right? So I just forgot. So for I, so it will be taking the value of range. Okay, so then I'm just starting time using time dot time, and next you will be finding this list dot map. You are mapping with respect to lambda, you are multiplying them, and list 1 and list 2. So list multiplication, you are just doing a multiplication. And what exactly is this lambda? So it is a very special keyword. Okay, so Python lambda. Okay, so you will find much documentation. So basically we'll just open random one. So it is a small anonymous for function. Okay, so basically you are creating a small function, so something like this, lambda a of a, so it is like x. Okay, so that is how it is like created, and it is used to avoid few functions. So here whenever you're telling x comma y, it will be multiplied, okay, x comma y into multiplication over here, okay. And if you avoid this, maybe you will get up ending an error, because you are not supposed to send this function within the map, okay. So that is the reason you are using it. So here it is expecting a small function, since you have not created a function, so you are using the lambda to create the function, okay. So, and the parameters, these are nothing but the parameters which you pass through to a function, okay. And you are ending the time, you are actually getting the time over here at this instant and this instant, and subtracting the end time at start time, you will get the final execution time. So it is taking around 0.018. I think it is pretty fast, okay. But let us see how exactly our uh, array numpy takes, okay. So we are creating two arrays, the same thing, direct multiplication. It is not this list of map of any function, and we'll just execute that. So you can see it is like 0.01, okay. So it is almost like 18 times, right? So it is like numpy is consuming 18 times faster, okay. So you can do that, and also like maybe you can find out the difference between list time and array time. So that like it is directly, you can see over here it is 18 times faster, okay. So that is with respect to all the few of the functions. So again there are more functions over here. So again you can just refer the documentation. So random and there is one function known as a reshape. So if you want to convert a 2D dimensional into 3D dimensional, you can directly search here. So you can see character reshape, but I need in numpy, okay. So numpy reshape over here. So here it is taking for transpose, as I was telling. So it is like 3 cross 2, like a range is defined. So it is like the order would be 0 2 4 1 3 5, and that is converted into transpose, okay. So basically this is the transpose, like this is the range which you are defining, and taking transpose is like this, okay. So it is taking 0 1 2 3 4 5, okay. So again these are the formulas what you are using, and also you will take reval again, check out what exactly is a reval, okay. So it is for doing the reshaping, okay. So you can do this whenever it is required to change dimensions or something. So again dimensions and all, if at all if we work on something like dimensional reductional functionalities or projects, then it will make more sense why exactly we need this a range reshape functions and all. So that is in particular to our course related. So that's all from numpy. In the next videos we'll learn about matplotlib.